Hello children. Yesterday we discussed about a pair of linear equations in two variables. Just by checking the values of the coefficients, we understood what type of graph we will get. So three types of graphs we understood yesterday. The lines may intersect each other and we will have a single or unique solution. If the lines are parallel, then the pair of equations will have no solutions. If the lines coincide on each other, we will have infinitely many solutions. So we have a new term here called consistency. So how to check whether they are consistent or inconsistent? Let us take three examples. I have written three pair of equations and let us check whether they are consistent or inconsistent. So let us write them in the standard form. So this can be written as 2x plus 4y minus 9 is equal to 0. 6x plus 12y minus 27 is equal to 0. So let us write the values of a1, a2. a1 is equal to 2, a2 is equal to 6. b1 is equal to 4, b2 is equal to plus 12. C1 is equal to minus 9, C2 is equal to minus 27. So when we divide these, let us see what we get. 2 ones are 2 threes are, it is 1 by 3. 4 ones are 4 threes are 1 by 3. So minus cancels 1 and it is 3. It is also 1 by 3. You can see all the three ratios are equal to each other. As we saw yesterday, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. How are the lines if all the three ratios are equal? All the three lines coincide. All the two lines coincides. So as you can see, if the lines coincides, we will have infinitely many solutions. If infinitely many solution, then we can tell that they are consistent but dependent. But what we can tell about the consistency? If we get solution, then they are consistent solution. If they do not have solution, then we can tell they are inconsistent. Let us check the second example. So standard form can be written as x minus 8y minus 3 equal to 0. 2x minus 6y minus 10 is equal to 0. So a1 here will be 1, a2 here will be 2, b1 here will be minus 8, b2 here will be minus 6, c1 is equal to minus 3, c2 is equal to minus 10. When we divide them, what do we get? Here we get 1 by 2. Here we get 4 by 3, here we get 3 by 10. As you can see, none of these ratios are equal to each other. So you can tell a1 by a2 is not equal to b1 by b2, which is not equal to c1 by c2. If all the three ratios are not equal to each other, then the lines intersect. If they intersect, how many solutions? One or unique solution. So we are getting a solution here, therefore the solutions are consistent. Let us check the third example. So standard form, x plus 3y minus 15 is equal to 0. 3x plus 9y minus 20 is equal to 0. Here a1 is 1, a2 is 3, b1 is 3, b2 is 9. C1 is minus 15, C2 is minus 20. So when we divide, so it will be 1 by 3, 1 by 3, 3 by 4. As you can see, the first two ratios are equal, but the last ratio is not equal. You can write it as a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. So we saw this relation, then the lines are parallel to each other. If the lines are parallel to each other, then we do not have any solution. We can write no solution. If we do not have any solution, so we can tell that the solutions are inconsistent. So what we can tell about the consistency? If we have solution, then they are consistent. If we do not have solution, then we can tell they are inconsistent. If all the ratios are equal, we get infinitely many solutions as the lines coincides in the graph. They are consistent and dependent solution. If they intersect, we will have one solution or unique solution which are consistent. If the lines are parallel, if the first two ratios are equal and it is not equal to the last ratio, then we do not have any solution. Therefore, the solutions are inconsistent. Let us solve the difficulties of the exercise 3.1. Let me read out the question. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also 3 years from now, I shall be 3 times as old as you will be. Isn't it interesting? Represent this situation algebraically and graphically. So there are two people here, Aftab and Aftab's daughter. Both will be our variables. Let the present age of Aftab be x, let the present age of Aftab's daughter be y. 7 years ago, what would have been the age of Aftab? So we can tell that Aftab will be x minus 7 and the daughter would have been y minus 7. According to the situation, the age of Aftab was 7 times the age of the daughter. So when we rewrite the equation, we will get as x minus 7y plus 42 is equal to 0. After 3 years, the situation is as follows. Aftab will be 3 times the age of daughter. So after 3 years, definitely if Aftab is 40 today, he will be 43, x plus 3. So 3 times the daughter age. So when we again rewrite, we will get the second equation, that is x minus 3y plus 3 minus 9 is equal to 0. So when we resolve it, x minus 3y minus 6 will be equal to 0, equation 2. So we have represented it algebraically. You have to know how to do it graphically. Shall we do it graphically? So one example I will tell you today. Again I will discuss the second example. X minus 7y plus 42 is equal to 0. Except x, take everything to the right side. So it will be x is equal to 7y minus 42. Now you have to make a table with at least 4 values actually. Go on substituting the value of y as y is in the RHS. So let us consider, let y to be 10. If y is 10, x becomes 7 into 10 minus 42. 7 into 10 gives 70 minus 42. What is 70 minus 42? It is 28. Let us consider y to be equal to 9. If y is equal to 9, x will be equal to 7 into 9 minus 42. 7 9s are 63. 63 minus 42. What is 63 minus 42? It will be 21. If y is equal to 8, x will be equal to 7 into 8 minus 42. 7 into 8 is 56 minus 42. 58 minus 42 gives 14. 7. Y is equal to 7. X is equal to 7 into 7 minus 42, which gives 49 minus 42, which is equal to 7. So we have the 4 values here. You can draw the graph and you will get a straight line. When you solve for the second equation, you will get the table as follows. Try to draw the graph and find the value of x and y. The second problem of the exercise is as follows. The coach of a cricket team buys 3 bats and 6 balls for 3,900 rupees. Later she buys another bat and 3 more balls of the same kind for rupees 1,300. Represent this situation algebraically and geometrically. So I will convert the verbal statement into algebraic form. Children, you have to convert it into the geometrical form, that is graphically. So here we have two variables, that is a bat and a ball. We will write it as let the cost of bat be x, let the cost of ball be y. According to the situation, coach of a cricket team buys 3 bats and 6 balls for rupees 3,900. That will be our first equation. Second equation, later she buys another bat, single bat, and 3 more balls for rupees 1,300. So that will be our second equation. Isn't it easy and interesting? Let us take the third example now. The cost of 2 kg of apples and 1 kg of grapes on a day was found to be 160 rupees. After a month, the cost of 4 kg of apples and 2 kg of grapes is rupees 300. Represent the situation algebraically and geometrically. Here also we will have two variables. That is, there are 2 types of fruits given here in the question, apple and grape. We will take it as let the cost of apple be x, let the cost of grapes be y. So in the first day, how many kg of apples? The cost of 2 kg apples and 1 kg of grape, 1 into y, was found out to be 160 rupees. After a month, 4 kg of apples, 4 into x, plus 2 into y, 2 kg of grapes costed 300 rupees. Was it simple? We successfully converted the verbal problems into the algebraic form. Now it's your duty to convert them geometrically by drawing 2 tables each in these questions and draw the graph. Before you draw the graph, once check with the coefficients and the relation whether we will get intersecting line, coinciding line, or the lines will be parallel.